In the last video, I think I recall remarking that wouldn't it be neat if I had a similar example with some numbers, and I guess I forgot I do. This is it. So it says, suppose that a toy rocket is propelled straight upward by a small flammable solid rocket engine. The engine expends its solid fuel at a rate of 24 grams per second and leaves the engine as exhaust at a speed of 350 meters per second. Given that the toy rocket has a mass of 412 grams, what is its acceleration? Now recognize the mass of the toy rocket would be decreasing in time, so the acceleration we're going to solve for is only at the instant that it has 412 grams, because if it's burning its fuel at a rate of 24 grams per second, well, a second later you can drop this by 24 and the answer would change. Now, I already did the analysis for this, so I think I just need to figure out what numbers do I plug in for what, right? And in that sense, if I look at all the things in this equation here, and I go back and look at the question there, I think that 24 grams per second is clearly the delta M over delta T, or maybe I could say that is that in absolute values. That's why I sometimes feel like the absolute values is unnecessary, as long as you remember it's got to be positive, but I suppose if you forgot, it's handy, right? The 350 meters per second is the exhaust velocity, so we can notate that there. And then, of course, the total mass of the rocket at that instant is 412 grams. And we all remember that G is 9.81 meters per second squared. So really here, I'm going to put in 350 meters per second. I think I'm not going to bother converting the masses again, because I think, as with an example we have with the rocket car, those masses are going to cancel out when we look at how this plays out. So 24 grams per second here, so you can see those 2 grams would cancel, right? And remember, this G is not a gram, right? That is G as in 9.81 meters per second squared G. So that's the last thing we're going to do, is do a minus 9.81 meters per second squared. And again, units wise, I'll cross through these two, so we'll have some number of meters per second squared minus a number of meters per second squared. That all checks out. I can put that whole expression without the units in my calculator, and my calculator says it's like 10.5783, etc. Maybe, let me see, maybe 10.6 is what I could round to there. 10.6. That's what I think is the highest likelihood of matching my slide if we follow sig fig rules, which I've often said I'm not a huge fan of anyways, but there it is. It does help me to at least match what my slides have.